Excellent. Welcome to lesson 4 in our physical behavior of matter series. We're going to cover heat flow and cooling and heating curves in this lesson. So our target here is to be able to identify phase changes in heat and heat changes in using heating and cooling curves. That's the point. Okay. So heating and cooling curves are pretty straightforward. They're graphs, okay? They represent the heating or cooling of a substance from its solid temperature all the way up through its gas phase. It's constantly being heated. That's what the curve is supposed to show us, okay? Now, kinetic and potential energy are related to heating and cooling curves because I mentioned in the last video, when kinetic energy increases, potential decreases, and vice versa. When potential energy goes up, kinetic energy goes down. And potential energy in chemistry is the energy of position. So it's in the solids and liquids and the gas phases that we really pay attention to potential energy and how it's changing. In these graphs, when temperature is changing, kinetic energy is changing, because temperature and kinetic energy are very closely related. All right. Those are the slants in the graphs. So the slanted portions show temperature changing. Read to the y-axis. You'll see temperature is increasing. That's where kinetic energy is increasing. Ba-bum, ba-ba-bum, ba-ba-bum. There it is. Okay. Now, in these graphs, potential energy is changing when the temperature is constant because the phase of matter is changing. It's going from a solid to a liquid or from a liquid to a gas. That's where the potential energy is changing, the energy of position. And those are the flat portions of the graphs. Ba-ba-bum, ba-ba-bum, ba-ba-bum. So every complete heating or cooling curves have three slants and 2 flats. Always a thing to remember. Okay. To draw, label, and interpret a heating curve, it's pretty straightforward. You got a y-axis and an x-axis. Y is always temperature, and x is always time. Okay. Then we draw slant, flat, slant, flat, slant to show the heating curve. Then we want to label it up. The lowest portion is the solid, lowest temperature. The melting point is when the solid and the liquid are happening at the same time, flat. Okay. Then we've got our liquid phase, all liquid present here. Temperature starts to change again, increase, until it hits the boiling point, which is where the liquid and gas are present, and we can read it from the graph. The last phase of matter represented is the, you guessed it, gas phase. Okay, so the kinetic energy is changing in the slants, and the potential energy is changing in the flats, where the material is going through a phase change. Potential energy, phase change. Kinetic energy, temperature change. Remember it back and forth. Kinetic energy, temperature change. Potential energy, phase change. Remember it. Okay. Let's find our values from the curve. So where the melting point is the lower flat. Where the boiling point is the higher flat. Period. End of story. Memorize it. Where are we only a solid? In the lowest slant. Liquid, middle slant. Gas, highest slant. Okay, so these are the only phases of matter present in the slants. Solid, liquid, gas. Depending on which slant you're looking at, different phase of matter. Where are we having multiple phases of matter? Well, in the flat portions, where the material is changing from a solid to a liquid, lower flat, or a liquid to a gas, the higher flat, we've got both solids and liquids, or liquids and gases present. Okay, you'll never have a solid and a gas present at the same time on one of these graphs. The intervals that show kinetic energy changing are all the slants. And the intervals that show potential energy changing are all of the flats. Now we're going to label up another curve, and it looks very same, but a little different. Y-axis, x-axis, temperature, and time. Same, hasn't changed there. But now we're showing a cooling curve. So we got to start high and go low. Slant, flat, slant, flat, slant. Again, same profile of the curve, but it's coming down in temperature this time. Gas is at the high end. Condensation in the first flat, that's the condensation point. It's the same temperature as the boiling point, by the way. Then we've got liquid in the middle. Okay. And then we've got the fusion, freezing point. Solid and liquid are present. And then finally, we would have the solid phase, the lowest slant on our graph. Energies are changing. Kinetic energy changes in the slants every single time. And then we have potential energy changing in the flats. The energy of position changes during those times. Okay. And let's see. Let's label up our curve, finding the condensation and freezing point. Well, these are the flat points. The condensation point is the higher flat, and the freezing point is the lower flat. End of story. Where are our solids, liquids, and gases only? Again, it's the slants, but it's the highest, the middle, and the lowest. So you got to look at the temperature to figure out if it's a gas or a solid. The higher the temperature, the more likely it's to be the gas phase. So look at the shape, the profile of the curve, decide which one's the gas, which one's the solid. The liquid's always in the middle, so you got to decide which side's the solid, which side's the liquid. Okay. Only the slants, though. Well, we've got solids and liquids, mixed phases at two different points. The higher flat is we got both liquid and gas, and the lower flat is where we got a solid and a liquid present. The intervals that show kinetic energy changing are the slants, always. Kinetic energy changes equals temperature changes. So read the graph's axes, you can infer this answer. And potential energy changing is where the flats are. So memorize the flat is where energy of position is changing. Potential energy is energy of position. So the flats are showing you potential energy changes. Exothermic and endothermic phase changes. Okay, these are what's going on in these graphs. Okay, we've got energy changing, cooling, exothermic. Heat is leaving the system. So as a water vapor turns into a liquid and then into ice, heat is exiting the system. So we call that exothermic. Heat is being released. Bye-bye. See you later. It's going somewhere else. Then we've got the opposite, the heating portions. When we take ice, solid, to a liquid, and then to a gas, we have to add heat. So the system, being the ice cube or the beaker of water, has to absorb heat. Heat enters that system. So we call that endothermic, where heat's coming in and causing the matter to change its position and kinetic energy. And overall, we call that heating up. The temperature rises, but it also causes the phase change as well. And that brings us to the end of this basic overview of what heating and cooling curves look like. Remember to where to label, what to label, how heat moves between phase changes. Absorbing heat, rising from solid to liquid to gas, releasing heat, dropping from gas to liquid to solid. And that's all, folks. See you next lesson. Let me find this button here, and I'll turn off this here video.